All right, so welcome everybody to today's Aerial Robotics Working Group meeting, Community Working Group meeting. Today is the scientific or presentation meeting where we invite a guest to talk about their Aerial Robotics project or product. Before we start, I would like to like this very quick agenda for today. It's not going to be that complicated. First, I'm just going to have a couple of announcements. Then we're going to have a presentation by Duckietown about the Duckiedrone, and then we're going to reveal the topic for the next meeting in 2 weeks, and then of course like this some concluding remarks for today. So a couple of announcements, of course. ROSCON 2023 is coming very up, and the general price will end at the 1st of October, I think. So if you still want to go for a relatively okay price, you should probably order your tickets now. Just also like they're going to be aerial robotics talks on not this Thursday, but on the Thursday of ROSCON, which first of all is going to be Ramon. He's going to talk about just like aerial robotics in general, and pretty much like our adventures at this aerial robotics community group. And also there's also going to be a talk about Aerostack 2, which just got an official package release in the latest, I think the ROS Iron and Humble releases, so that's pretty cool. And also the aerial robotics landscape, that's documentation that we have started at the start of this community meeting, is growing quite nicely. So I would like to thank everybody that has contributed to that, and of course everybody that's joining the previous discussing meetings has, we have gotten quite some fuel for this landscape that we're trying to have, and it's quite big. We'll probably make a how do you call it? Apparently my volume is very low. Is everybody still able to hear me? Maybe let.
I can hear you well, Kimberly.
Yeah.
I can also hear you well.
Okay, perfect. Well, then it's probably the person speaker, but that's fine. Just to kind of conclude, so everybody that wants to kind of look at this list of documentation, it's very basic. It's just markdown files of the aerial robotic landscape. That's the link right here. We'll post the slides later. And then you can just add any information that's still missing to this landscape. So yeah. And then, without further ado, a presentation by Duckietown, by Jacopo, Tani, and Davide Iafrate. I'm probably pronouncing your last name completely wrong. I don't know,
it's a common mistake. People pronounce it with an L at the beginning, but it's an I.
It's Iafrate.
Sort of, yeah.
Yeah, okay. All right. But anyway, so they're from Duckietown. So if anybody knows the Duckybot, that's a small robotic platform with a camera that they use for their massive online course. And a lot of universities and a lot of institutes are using them. And they also, I found out, made a drone as well. So that's why I've invited them today to give a presentation about that. So I'm just going to share my slides. Then you guys can share your slides, and
I will
go for
start. Can you see my screen?
It's all visible.
Great. So first of all, let me thank you very much for the introduction and for inviting us. I must say that actually, we kind of discovered you through some of your LinkedIn posts before you reached out, and we had you on our internal radar, and we were studying all the various nice things that you guys were producing and thinking about how to potentially collaborate. And then when we received your email, we were really happy. So we're glad to make this presentation, and we hope that that you'll find it interesting, and we can then take it from there to figure out how to do some future steps together. So my name is Jacopo Tani. I am one of the co-founders and the CEO of Duckietown. My background is in aerospace engineering. And today we're going to give you a small introduction about Duckietown along with my colleague, Davide Iafrate. And we will do a little bit of how did I pronounce it, Davide? we'll be doing a little bit of a tandem presentation. So at some point, there's going to be a break. I think that the spirit of this talk is to be colloquial. So feel free to interrupt at any moment and to ask questions. We'll try to keep a lot of time at the end for Q&A anyways. So the general idea of today is to give you a small introduction to Duckietown, the Duckietown project, Duckietown as a company, what do we do, why, what are we about, then focus on the actual Duckietown sky effort within Duckietown, and in particular the Duckiedrone, and then leave it up for questions, and we can hopefully have an interesting chat. So Duckietown is an American-Swiss education technology startup company. We are on a mission to basically democratize the access to the science and technology of robot autonomy. We started as an experimental class, basically, for the master's students of the Computer Science and Artificial Intelligence Lab at MIT back in 2016. And before we realized what was going on, we kind of had a pickle in our hands, as many universities and various entities have started requesting to join the project. So in time, we started bringing our materials to more institutions. We went through a Kickstarter, trying to reduce, let's say, the barriers of entry to the project. And before we realized that we are now basically serving roughly 200 universities, more or less 150 companies. We had in the order of 10,000 alumni and have delivered robots in 64 countries. Basically, we operate from Boston, where our, let's call it an HQ is. We have staff pretty much all over the world. We were working from home and delocalized way before smart working was a thing, before COVID hit. So we found ourselves very ready for the change, and we distribute our robots from pretty much all over the world. So Duckietown is fundamentally a technical platform that is designed for teaching, learning, and doing research on mobile robotics. Our focus is mostly higher education, so we talk mostly with universities and university professors, and we provide this kind of ecosystem for teaching, so for delivering learning experiences that are engaging and people can learn useful skills out of them. Basically, it's made of several components that are work together and are integrated. And of course, the most tangible, the most visible part is that of the hardware. We have self-driving cars, of course, model self-driving cars in the form of educational kits. We have the drones, which we're going to talk about today, and the actual proper Duckietown, that is this modular, let's say, urban environment that can be transformed into a smart city. We have then all sorts of software tools. We have this thing called the Duckietown shell that is basically a development environment that takes away some of the gritty details of development and robotics. And we have a number of simulators. We provide pedagogical materials in the form of curricula, classes, videos, slides, activities, exercises, courses. We have this massive open online course that we're going to talk a little bit more in detail about later. And we have this evaluation infrastructure, so which you can imagine as some sort of an auto grader if you are a professor teaching a class, or you can think it as a reproducible robotics evaluation system. Let's call it a low-cost backend system or something like that if you're doing research. And throughout the years, we've been growing a community that basically mostly resides on Slack, of instructors, learners, and professionals pretty much worldwide. The idea of Duckietown is to basically try to unveil a little bit of the mystery that there is behind robot autonomy, and to make it easy, but at the same time not shy away from what is the fundamental complexity of the subject. So all this platform that we created and that we make available for pretty much anybody around the world is, of course, a cool thing, but it's a means to an end for us, right? So we want to kind of push this idea of a new model for education, where the learning experience is what really matters, and we want to kind of make people understand, or students, learners understand that getting into these things can be joyful, and you can have an internal motivation. You don't need to work and study for the grade or for social pressures or things like this, but actually create some sort of direct contact between you and nature, fundamentally, and the laws of physics through robotics, which is a beautiful subject. And in particular, robot autonomy, because it's this effort to try to somehow give life to machines now, which is very exciting and very profound and very challenging at different levels. We really care that all our materials and technology is accessible. And by that, we mean that, of course, it's affordable, although that means different things in different places around the world. It's inclusive in the sense that it's the choice of the ducky and the let's say if you want borderline silly appearance as a way to try to bring the stereotype of robotics out of the big robots that you find in industrial sceneries that are powerful, precise, fast, all these things that are typically associated to robotics. Duckietown was by design made quite the opposite. Slow, imprecise, cute, colorful, but at the same time, the technology, the science, the challenges that are behind it are as difficult as those nastier big robots that are around. And of course, available worldwide with ease. Basically, through a click, people can have this classroom materials with all the infrastructure delivered at their door, pretty much anywhere around the world, where the asterisk, of course, stands for the necessary, let's say, legal limitations. And one of the things that we did a few years ago was launching the first edition of Self-Driving Cars with Duckietown, which is a massive open online course. It was, to the best of our knowledge, the first ever robot autonomy massive open online course with hardware that was ever provided. It's hosted on the edX platform that is a well-known, let's say, MOOC infrastructure. And thanks to a collaboration with various universities, we created this course that has that basically brings learners through what we call a grand tour of robotics. Now, so it goes from the very basics of how do I set up Ubuntu on my computer, how do I take this bunch of metal bits and pieces and put them together to exploring how to make this a self-driving car autonomous and make it drive in people's living rooms or offices or labs or whatever it is. And yeah, so we had roughly 10,000 people enrolled from pretty much everywhere around the world. And the course is free, of course, with the hardware being optional but recommended. And we put lots of effort in trying to make, let's say, the whole learning experience as reproducible as possible. As I'm sure you all are very aware of, robotics is messy, right? There's lots of bits and pieces that come together. There's the hardware, there's the software, there's the environment that plays a big role. And when you have many people around the world trying to go through these things in different environments that we cannot control, it's important to have a software infrastructure that guarantees as much as possible the reproducibility of outcomes, right? And yeah, so this is the part where the drones come in. We have started working on Duckiedrones a little bit later in the history of Duckietown, let's say. So the project is to some degree less mature than the self-driving car aspects, despite we are now moving at full steam in both directions. Our idea is to create this integrated system where, again, what matters most to us is the pedagogy, is the teaching, is the learning, right? So whether it's this robot or that robot, if it drives, if it flies, swims one day, if it's a weird, spatially decentralized, smart city robot, that doesn't really matter, right? What we want people to focus on are the things that are common, right? All the architectures that you have to deploy for autonomy, and all the tools and the workflows and the methods that are important to get these things to work. So the Duckietown Sky initiative was actually originates from an effort from Professor Stephanie Tellix of Brown University and her team. And Duckietown was supporting, let's say, from the productization aspect. So basically, we helped with the design of the robot and with the manufacturing, the distribution, and the support of all the learners that were engaging in these experiences. And of course, we acknowledge and are very thankful for the funding that we received from Amazon Robotics in these early efforts and even later on. The first edition of the Duckiedrone was basically a do-it-yourself, off-the-shelf components, Raspberry Pi's based, fully autonomous drone. So one of our design, let's say, choices and constraints, if you want, is the choice to use Raspberry Pis because of the community and, let's say, again, the accessibility aspect. Pretty much anybody, I mean, many people have Raspberry Pis lying around, and they can always reuse them if they buy them in the drone kit for other things. And the idea was to create a set of learning experiences that, again, would bring the learners from a box of parts to having a fully autonomous drone. Maybe not one that does competitive racing, but the one that exposes learners to all the important parts of the software architecture and of autonomy. You know, so going from let's say nothing to estimation, control, localization, and SLAM. And the thing about later on, I mean, after a couple of years of using this this first edition, we saw that there was traction, there was interest, and so we started fixing some of the most obvious flaws that there were in the first design. And some of them were hardware, some of them were related to the software architecture. And lots of effort went into the documentation. Of course, all of these are continuously work in progress parts, but today we have now this nice little happy yellow ducky box that can be delivered to anyone around the world. And the spirit is to make it as all inclusive as possible. Now, given the target of the students in this let's say Duckiedrone experience was late high school, early undergrad, let's say. We wanted not to hide some of the lower aspects like soldering and things like this. So we don't provide soldering materials inside the kit, but apart from that, all the things that are necessary are in there. And as I mentioned, the experience that we want to provide is something that allows the students to really go step by step from a box of parts to having an autonomous flying drone. So we go through the components, we go through the whole safety procedures, the assembling, the soldering, all the basic setup of the, let's say, working environment. So how do you put Linux on your computer, basics of networking, how to use ROS, of course, for middleware, all the parts of the configuration, the calibration, of course, the exciting part of making the robot fly, which is something that makes everybody very excited and stimulates for further, let's say, engagement. And then we go back and kind of delve a little bit deeper in each and every one of the components, every ROS node that has the various estimation, control, localization parts. And yeah, so I think that I can leave maybe the floor to Davide if you would like to talk more about the drone.
Yes.
You want me to stop sharing?
Yes, please.
Go ahead.
Okay. So hi, I'm Davide Iafrate, and I've been working with Duckietown since the beginning of the year on the Duckiedrone. My background is in aerospace engineering. I want to give you an overview of the hardware of the drone and how the software is structured. So for the hardware, we have a minimal sensing suite composed of a camera, a time of flight sensor, and an IMU. And we have 4 PWM motors controlled by the ESCs for actuation. And for power distribution, we have a power distribution board, and of course, we have a battery. For the flight controller, we chose an F3 flight controller using Clean Flight V3. And we provide a pre-configured setting file to restore on the flight controller to make it compatible with the software we use. And for the main computation unit, we employ Raspberry Pi 3B Plus, which has a quad-core ARM platform and is a good fit for the power-weight balance that we need on the drone. For this, we provide a Flash and FlyOS image that is ready to be flashed and to connect with the laptop and fly the drone. Regarding the autonomy stack, we have the 3 nodes communicating with the sensors and the flight controllers. Flight controller, we use the multi-V serial protocol for communication with the flight controller. And we have 2 types of control. We have a velocity control, which employs the optical flow from the camera, and a position control that uses feature detection from the camera. We also have a SLAM node that runs offline on the base station. We have developed this development workflow using something called the DT projects, which are a templated software entity that leverage the Duckietown shell, which is a shell with all the commands that we use. And it's designed to be usable, maintainable, and modular. This type of projects and the DTS allow us to run the code on the dev machine and connect it to the robot, or run the code directly on the robot itself. And we have a developer manual available for this at this link. One of the highlights of the drone is this dashboard interface, which is a browser-based UI that allows us to interact with the drone and see its status. It's integrated also with the more mature self-driving cars UI. Regarding onboard development, we have an onboard IDE that is accessible through the dashboard, which is an instance of VS Code. And this allows us to have an entry-level development that is device independent. So the users just need a web browser and can connect to the dashboard, switch to the IDE and code. We have thorough documentation, which starts from the operation manual, which details everything from the components to the first flight and everything in between. So safety, assembly, and the setup of the software. We also provide an instructor manual for the instructors. We have developed these learning experiences for the drone that are based on Jupyter notebooks and are designed to be modular learning activities that allow us to deploy the code both in simulation and on hardware, and run on a Dockerized instance of VS Code, and also we have a VNC environment for more complex operations. We have several types of LX regarding sensors, PID, filtering, localization, and SLAM. And also we provide a developer manual for instructors that want to develop their own LXs. So this is what we currently have now, and I want to show you a roadmap of what we did in the past and where we're going in the future. Regarding, we have 2 aspects that we are evolving rapidly. So it's the simulation, which in the past used simple Python 1D simulators and ROS specs. Currently runs inside the Jupyter notebook. But in the coming year, we want to transition to this Tachymatrix simulator, which is a photorealistic simulator based on Unity that will allow us through Dockerization to also have software and hardware in the loop. Regarding pedagogy, we started with the lectures by Professor Telex from Brown University. And we currently have these Duckietown LXs that I've shown you, but we are moving towards a mini MOOC series that has one specific LX for individual topic. So we're designing this to be very modular and focused. For the next iteration of the drone, we have several improvements in the pipeline, starting from the hardware, where we're going to move to Raspberry Pi 4 to have more compute power. We're moving to improved flight hardware in terms of flight controllers, and we want to make the Duckiedrone safer for indoor use. The autonomy stack is also evolving to the latest technologies. So we're going to support ROS 2 and Betaflight, and eventually also the peaks for autopilot. And regarding the UI and user experiences, we are also making several improvements in terms of simplifying the initial setup, having a tighter integration with the overall Duckietown ecosystem, and having a broader OS compatibility for the base station laptops. Okay, I'm gonna leave the word to Jacopo for the end of the presentation.
Thank you, Davide. Maybe you can continue sharing and just pass on to the next slide when it's time. So I wanted to spend just an extra word on this mini MOOC series. We had let's say gathered some experience with the self-driving car aspects of the massive open online course, and we learned, of course, a lot in the process. And in collaboration with Brown, we're now developing basically a series of MOOCs, which are going to be a little bit shorter than the one we have now. So maybe targeting 5 to 6 weeks of learning experience each. And the tentative plan is to really make it from how to build a drone to how to do say ML-based autonomy, through a series of 7 different courses that will, of course, be developed throughout the years. The idea is always to have the course to be free for all people involved, but to engage as much as possible academic and industry leaders to bring their perspective, both in terms of expertise, technical expertise, and in terms of providing an overview of what is the state of drone autonomy in the real world for real world applications. So from, I don't know, warehouse management to sending drones on Mars and things like this. And from this perspective, we definitely hope to engage as many of you as possible if you want to collaborate, and are looking to get sponsorships from various industrial partners. Pass on to the next slide, Davide, please. Yeah, and this is pretty much it. So we kept it maybe a little bit longer than Kimberly had recommended us. I hope it was interesting, and we're happy now to get any questions or comments, doubts, and have a conversation. And do follow us on LinkedIn, please.
Yeah, thank you, Jacopo and Davide. That was a really interesting presentation, and you guys did it perfectly. Like we also to keep in mind that they started a little bit later, and I had an introduction, so you guys got it really well within like 20-30 minutes, and plenty of time for questions. Anybody have any questions about this presentation, or about the Duckiedrone or to Duckietown? Just either ask them in the chat. Yeah, Vanilla, go for it.
Hi, thank you for this very interesting presentation. My question is, I noticed that C++ is not included. What was the decision behind that?
So the general idea is to focus on the learning aspects rather than the performance ones. So while it is true that C++ is more, of course, more efficient, and we do not exclude using it at some level in the software architecture, a choice was made to use Python because it's more, let's say, popular and more, let's say, widespread in the learners community. Of course, we do sacrifice some performance due to that, but that was the underlying thinking. Does it answer your question?
Yes. And then I do have a second question, if I may.
Of course.
So you mentioned that in some countries you have restrictions. So I've experienced this myself. I'm developing drones from South Africa, and I couldn't get a real sense from Intel. They just refused to ship it here. And so I started using other cameras. And so I was wondering how you get around that. Do you ship the entire package as a whole with the sensors declared? And how do you provide the kit to countries that have import restrictions?
So we do provide the kits as a whole, so they come with all the things you need, including the batteries. We have put effort into compliance for international shipping, so everything is certified, tested, and we work with couriers to check all the boxes that are needed. Now, this said that there are some countries that we're not allowed to ship to or to do business with because of international sanctions. Those are things that are way above our head, but we have to comply with. Specifically for South Africa, we do have users in South Africa, and we have shipped to South Africa many times. We never experienced the particular constraints. I cannot speak to the particular case you mentioned of the Intel camera. I guess the technology there is more advanced, so possibly it's ITAR controlled in a different way than the Duckietown hardware is. Duckietown hardware is fundamentally off-the-shelf stuff, so we do not have restrictions from that perspective. But every country is a thing in its own. Like if you ship to Egypt, then cameras are a problem. If you ship to maybe other countries, India, batteries are an issue, or things like this, right? But we do have extensive experience in shipping around the world. We do ship directly, as well as have a network of distributors that are more expert than us on the local, let's say, limitations. So we have these distributors around the world in different countries. We partner even with some, let's say, tier 1 hardware distributors that ship pretty much around the world. I wouldn't say everywhere, but in dozens of countries. So yeah, it's a challenge. There's different levels of complexity. Some is related to technology, some is related to the politics. But we do our best to try and be as compliant as we can from our perspective, and then we do the best we can with what we have.
Awesome.
All right, so there is a couple of questions in the chat, but before I'm going to move to that, I first want to give the word to Mayank. So go for it.
Hey, thanks a lot. Lovely presentation. And I really like your journey because there were so many questions I had as you introduced the architecture of the V1 that you answered already and things you're working on. So I was really glad to see like the move to beta flight, or you showed, I think, the SpeedV F405 for the flight controller. Those are like really interesting and a nice upgrade in terms of your architecture. I would love to help out, like you've mentioned, potential avenues for collaboration. I do have experience with these building FPV drones with the same parts, and it'll be great what we can do here. One suggestion or question I have is, I've seen this being done with some drone kits earlier, where there is like a beginner mode and then a pro mode. So I understand where you're coming from in terms of making it learner friendly and maybe even for school students and experts. But I feel like the platform you are setting out to make would be really highly performant. It'll be great if there is like a child lock or like a training wheels kind of functionality, which limits the pitch angle or the roll angle initially. But as you put in number of flying hours, or if you demonstrate certain other skills, you could make the agility of the drone a lot more aggressive. I think if you can offer that flexibility, there is potential for this platform to be really used like beyond a smaller community, which is what we've seen very often with platforms like the Raspberry Pi. It was kind of made for school students to show them what a computer looks like, and the hobbyist community and the hacker community picked it up. So I feel you have a real opportunity with the Duckiedrone to do something similar while not compromising on safety. And I think that would be a nice approach. I want to also build up on Bono's question. If you could have a list of countries you've already shipped to, that would be great. I, for one, know that India would be challenging. Batteries might not directly work. If you already have people whom you've shipped to in India, that will be great knowledge for me instead of going through the pain of trying to order, spending money, and then figuring out that, hey, there are rules over there. So just a list of countries you've shipped to them in the past, and if you maintain it once every benefit for people um, in general. Um, yeah, and open questions I have is, you mentioned you have a base station in the loop. So do you change the complexity of the autonomy stack depending on whether you're running things on board on the Pi versus on the base station? Like, do you only run monocular SLAM, which is lightweight on the Pi, but maybe you have a lot more compute on your laptop, so you run that? And how do you manage things like latencies and, guarantee performance with issues like that? Like, that's something which caught my eye.
Yank, those were 4 questions, not if I didn't miss any. So let me go in order, and please
Sure.
remind me if I missed something. So with respect to the increasing, let's say, in aggressiveness of performance and stuff, I think the child lock, let's say, constraint you mentioned is a brilliant idea. We hadn't really thought about it. So again, there are several ways to answer this question. I think so. One is, there are tons of very performant drones out there, right? So it depends really on the application that you use, and it's not our intent to go and compete with DJI or whatnot, right?
Of course.
So for us, the use case is very clear, and it's that to introduce learners to autonomy and to empower teachers, educators at various levels to play with these technologies in a very detailed manner, right? So making it as simple as possible, but yet not let's say, washing away the complexity that is part of the beauty of this thing, right? So we already have all the let's say, when we started introducing the drones, we already had all the self-driving cars, let's say, infrastructure that had been developed for several years already, because that was for historical reasons, let's say. And so we really wanted to have something that was more kind of shock and awe in terms of inspiring people. Like they say, the good instructor is the one that tells you stuff. The great instructor is the one that makes you happy. But the perfect instructor is the one that inspires you to go and search more. No, and flight is this thing that is beautiful, right? It's powerful. It's inspiring. And we wanted to try to engage especially learners that were a little bit younger / lower skill level than the ones we targeted already with the self-driving cars. The self-driving cars basically cover anything from undergrad to scientist level. There's over 400 publications or something last time I checked, done with or using or citing Duckietown. And so everything is already child locked, so to speak. Now, so in our application, people use them at home. People use, like, when there was the pandemic, we were having drone courses, like, say, in remote in a bunch of high schools in Providence, right, in Rhode Island, sorry. And we can definitely see, let's say, a scenario in which more experienced, more skilled users start pushing things a little bit more. We're happy to support it. I'm pretty sure that the more skilled users are able to do that on their own because the platform is open, right? So I maybe didn't mention this explicitly, and I see a few questions related to this. All the autonomy, basically all the code that runs on the drone is open, right? So you can double click and go and change pretty much whatever you want, right? So if you know what to do, you can remove the various limitations that we have placed and make the drone more aggressive. But that's not really the case for 99% of the users that we are targeting so far. Now, your second question was related to the list of countries. It's a little bit challenging for us to maintain this list because it changes, of course, dynamically. But if you go on our website, and this is a very funny thing because I'll tell you later. Maybe Davide, you can pull up duckietown.com on your computer if you can. Basically, you just scroll down like half a page and you find a map with a bunch of duckies that of course the positions are a little randomized, not to give away the addresses of the people that order, and the map is maybe 8 months old or something like that, so it's not super up to date, but it gives you a pretty good idea of what are the countries that we ship to. And India, we have tons of actually some of our biggest users are in India. And actually, we do have an official distributor in India as well. Again, we can ship directly, but we have a distributor there, and I am happy to share the actual website with you later if you want. And but if you go on our shop, which is get.duckietown.com, somewhere at the top there's actually a distributors link, and you will see the whole list of our distributors with the countries they serve. For anybody that has these kind of, let's say, worries, I suggest you just shoot us an email and we will look at your specific case and figure it out if possible. Definitely, there is no need to spend money and then figure out that it cannot happen, right? Let's say the common issues are related to custom clearance, right? And it's not, as we mentioned before, too much a matter of whether things are allowed or not, but it's more about, the taxes, the duties, the bureaucracy, the paperwork, and every country again is a particular use case, is a particular, let's say, story, and it's difficult to generalize. Like in the United States, pretty much anything you order up under $800, if I'm not mistaken, if memory serves well, doesn't need to you don't need to clear it. Basically, you don't need to pay any duties or taxes. India, in my experience, is one of the most complex countries in the world to deal with bureaucracy, but that's not because of the drones, it's because of bureaucracy. And I'm Italian, so I know my share of bureaucracy. But eventually we managed to get things through, right? So again, case by case, I suggest anybody who has these questions just to reach out, and we'll do our best to try and help. And if we can't help directly, we'll try to leverage some of our more experienced distributors. Now, you talked even about, you asked us something about the complexity of the levels of development based on let's say the host machine. So we are always facing this conundrum, right? That so imagine you're designing a drone that you want it to work in the public school system at high school level in the United States, for example, now, which is our biggest, let's say, market. There's huge limitations related to, for example, access to the internet, right? So there's some sort of a firewall. You need to be whitelisted. We are not Google, so it's a little bit difficult to enter that kind of conversation. And so there's a bunch of constraints that we have. So the short answer to your question is yes, of course, there are computational constraints. There are performance constraints. Depending what you do, where you do it, you get different levels of performance. Some of the things we talked about in the presentation are work in progress, right? So you can do it, but it doesn't really work well. And you've got the lags, you've got the computational saturations all the time. That's why we're pushing into using a more let's say, powerful onboard computer. So our spirit here is trying to offer versatility in the workflows, right? But at the same time, not trying to add too many constraints. So ideally, we want it to be a one-click solution. Like you press a button. So what is one of the challenges that typically instructors face when they teach these things, right? Like in robotics, there's so many different levels of complexity. There's the hardware, there's the software, there's development tools, there's how the things work together, and does your Wi-Fi work, and do you have access to the internet, or how's your subnet? It's like so many different things that typically confuse instructors before, which in theory should be the expert ones, right? Before even getting to the users, which are the learners. And so the Duckietown team is, especially the founding members, we're people that have extensive university experience teaching and doing research in these things. And we are kind of trying to send the message, hey, there's many choices. Trust us to get started. We made the basic choices for you, okay? And so sometimes you find yourself working in environments where the Raspberry Pi on board is the best thing you can do because you don't have a set of laptops to give to every student, right? It's too expensive, or maybe they use the Chromebooks because that's whatever it is that worked for them in the past and the deals they have. So again, performance is not the main focus here. It's about trying to demystify what's going on and getting people to do something that is meaningful, right? And then the hardware and the software, again, are open source. This means that they're open. I wouldn't use the word open source. I'm not sure 100% about the implications of it, but there is the possibility to do hardware mods, to add things, to modify the drivers, add sensors, add actuators, make things a little bit different, do new learning experiences, as Davide mentioned. So this means deploy code on the robot to do things that were totally different from the ones we originally imagined. So I don't know if I've been rambling or answered your question to some degree, but I hope this gives you an overview. I think I have the feeling that I missed one of your questions. Please remind me if I did.
I think you're good. The other was just a comment about collaboration, and we can take that offline.
Oh yeah, sure, 100%. Let's do it. I am super happy to invite you to our next development meeting, and we can take it a step at a time.
All right, there are also a couple of questions in the chat, so let me just kind of dictate them to you. So the first question was from Vignesh. Like if the Duckiedrone software is open source. So Davide has shared already the github.com/Duckietown. So that is so that's already there. Just saying, like if you're unsure about like open source, as long as you're using like Apache 2.0, MIT, or one of those open source licenses, that is considered open source.
Yeah, so our spirit here is that so Duckietown was born initially as completely open source. In time, as we became a for-profit company, we had to do some compromises. So the general idea is that all the code that runs on the robots, so all the autonomy code, all the science stuff, all the autonomous behaviors code, all the pedagogical materials, the classes, the exercise, that all of that is open source. All the good fun stuff is open source. Okay. All the boring things, which is all the backend that allows you to, for example, with one line of code, create your agent, deploy it in the simulator, see all the technical, let's say, performance metrics of whatever challenge you're trying to solve, then press one line of code without having to paste 62 different things, fighting with Docker containers and whatnot. You deploy it on the hardware. You can compare all the let's say the code that makes the learning experience joyful. We say that's not open source, right? So that is a little bit of our magic sauce, is what makes people, or specifically professors, save time, right? At the end of the day, that's the value that we provide to instructors, is that you get something that works, you save time, and you are not stressed, right? And so the secret sauce behind it is all the Duckietown backend, and that's not open source. But learners don't really need to access any of that.
And I guess, like, they can use they can look at the autonomy code and they can implement something themselves if they like.
100%. Like we provide baselines, right? So it's both for the cars and for the drones, we provide things that work out of the box.
Yeah.
We're not here to tell professors what they should or not teach. We provide recommendations and something that works. And we actually hope that at some point, when this picks up more, professors will feel comfortable enough to create and share their learning experiences, so that we can then distribute them for free to all the users around the world.
That sounds great. I just have to go to the next question, because I would like to have a couple of minutes at the end of the hour to have some announcements. So the other question that was also kind of like, I guess like it kind of goes back to what we already discussed before. Is it possible to implement custom controllers on the Duckiedrone?
Easy, yes.
Yeah.
I mean, Davide, feel free to answer in my place.
Yeah, we do not implement low-level controls in the flight controller, but we do everything from the angular set points and above. So velocity control, position control. Feel free to go on the LXs and play with those.
And I guess if they want to change anything, like in terms of attitude control, night control, something like that, then they would need to kind of dig into clean flight firmware and implement it there themselves.
Exactly,
but I guess, if it already works, then why touch it?
That's the engineering spirit.
Yes, except what probably control engineers will not agree, but yeah. Okay, so also the question is it possible to interface the Duckiedrone with MATLAB or simulations?
Well, with MATLAB currently no, but we do have the Duckimetrics, which is the simulator in the pipeline, which is he meant Simulink.
I see. Yeah, or like
see.
the MATLAB / simulation. So I guess MATLAB kind of includes Simulink, which is usually also used like in control engineering and yeah.
No. Was a design choice? I mean, the answer is no. Whether it can be done, maybe. Duckietown is a small team, so we have to make choices and try to focus and to deliver something that is as polished as possible. And at this point in time, it's difficult. I mean, we have to be careful not to spread ourselves too thin. And one of the choices we made was to focus on more, let's say, 2020s kind of technologies rather than the 90s engineering tools. But I love MATLAB and Simulink. I mean, I got my PhD with them, and but I wish there was we had more manpower to support even that part. But at the moment, we don't.
Right. Guess that will probably answer the question. Alex had a question of like, are you doing V-SLAM with a single camera?
Yeah, we use a monocular camera for SLAM.
All right. I guess that also answers that question. Very easy question to ask. Let's see if there's any other. Yeah, so like Bono is asking, how does one become a distributor?
Send us an email.
Okay.
We're happy to discuss. Very easy.
All right. And then the last question probably that we should ask for today is, they're using Raspberry Pi with ROS, so probably it's possible to use ROS on MATLAB to make some communication. Okay, yeah. That's kind of like, it goes back to the fact like, why you're not, if you're not using MATLAB, but people can use ROS to interface with the drone in that way. I guess that makes sense. Yeah. So to use ROS with MATLAB.
If I may add, if you by yourself develop some kind of integration with these kind of things, feel free to reach out and to us. We're happy to like give it exposure.
All right. I guess like if anybody has some more questions, like the contacts, like info@duckietown.com, partnership@duckietown.com as well, if you like to work together. And we're going to share all the slides as well later with the recording. So that will all be fine for sure. So I'm going to share my slides, if that's okay.
Yeah, definitely.
Thank you all very much for the questions.
Yeah.
Thank you.
Let me see if I can find. Of course, I closed my presentation, but just a couple of quick announcements before we close this meeting. So yeah, so this is very, very short because since last time we actually selected already a topic for the next discussion meeting, which was simulation. I couldn't actually host the last meeting, so that's why we did hardware instead, because it's more of Ramon's cup of tea. But that means is that we're not going to have a poll this time. Next, in 2 weeks, we're going to have our discussion presentation about discussion meeting about simulation. I hope that's fine for everybody, and I will make sure to honor the democratic process in the future. Let me see. All right. So yeah, so that's Wednesday, 11th of October is the next meeting at 2 p.m. Universal time. That we're going to discuss about simulation, and of course, like the GitHub organization for this working group is github.com/ROS Aerial. Yeah, where you can find like all the information about the community, all the meetings, and the aerial robotics landscape that I mentioned before. And of course, if you would like to also do a presentation about your aerial robotics project next time, which is in 4 weeks or 1 month, yeah, just send me an email or reach out to me in DM on Discord or Discourse. Yeah, because we don't we still have a slot open for next one. Yeah, that's all. So I would like to thank you all for coming and listening to Duckietown about the Duckiedrone and for joining. And I hope to see you guys for the next discussion meeting in 2 weeks. Well, There was somebody had a question or? No. All right. I'll just close the recording for now, and we can ask, and we can have a discussion after that as well. Thanks again.
Thank you.